Welcome to Mr. Honeycutt's math class. We're going to talk about inverse sine and inverse cosine. This is what these functions look like. So here is a sine function. And remember, we would have to use patty paper, and I think we did do this one time in class, and flip it around. And when we do, let's just kind of get some ideas here. So the domain of the inverse sine function is going to be the same as the range of sine. The range of sine was -1 to 1. So that means that that's going to be the domain of this. So it's going to go between this and this. Okay? And then the range actually ends up being between -pi/2 and +pi/2. Oh, actually, these are brackets because it does hit that point. And pi/2 is about a little more than 3.14 divided by 2 is about 1.57. So it's just going to be a little bit more than this and a little bit like that. So graphing these, I'll just sketch it real quick. It's going to look something like this. One thing to note, and I've actually thought about making students, when they draw this, like to actually show the endpoints, because that's one of the key differences between this and, say, the tangent function. The tangent function keeps going. It does look similar, but this inverse sine function does not. So there is no left-end behavior or right-end behavior, and it's increasing the whole time. There is a max there's absolutely a max at the point 1 pi/2, and there is a min, which is, this guy, right? And then there's a min over here at -1, -pi/2. So there absolutely are max and mins, though. It is increasing from the whole time. So from -1 to 1. There's some debate about whether these increasing intervals would be brackets or parentheses. Don't worry too much about that. Looking at arc cosine, this one looks quite a bit different if you graph it. And the domain is the same. It's going to be -1 to 1. The range is odd. It's strange. The range in this case ends up being between 0 and pi. So what it ends up looking like, let's see if I can get this right. About right there, a little more pi, right there. It's looking something like this. It's not bad. And again, it's got these endpoints here. We had to do that these ways because otherwise, if it continued on, it would not be a function. Because then it would have two outputs. Same thing with down there. Same thing with the sine function, by the way. If it went this way or this way, it would double back. So this is basically, what these are sections of a function that do not double back on themselves. All right, so that's the piece that we can use for the inverse. It's also why you have to pay very close attention when you're using inverses on the calculator to what quadrant you are in. So notice in this case, this is, for the sine function, this is quadrant 4 and quadrant 1. However, for the cosine function, it's working in quadrant 1 and then quadrant 2. So we're in quadrant 1 is from 0 to pi/2, and then quadrant 2 is from pi/2 to pi. Which is why, so for instance, with triangles, this is the reason why you can have donkey triangles. That when you use sine, you sometimes have to watch out for the another possible angle. It could be reflect a reference angle sort of thing. But with cosine, you don't. If it's a negative, like over here, so if your cosine is negative, what that tells you is that your angle is greater than 90 degrees, between 90 and 180 degrees on the triangle. So that's actually one of the things that's why this is very nice and why we think of this like this. It makes it very useful for cosines. So notice on this, it's always decreasing. Okay. So from -1 to 1. Oh, not increasing, decreasing. 1 to 1. It doesn't have right or left-hand behaviors, so we talked about. There is a max. The max would be at -1 and pi. These, by the way, these are coordinates, not intervals. Coordinates, coordinates, coordinates. And then this would be, the min is going to be at 1 and 0. Which makes sense, because what's the cosine of 0? It's 1. Well, the inverse cosine of 1 should have to then be 0. Hey, there it is. So this is what the inverse sine and inverse cosine functions look like. These are sometimes also called arc sine or arc cosine. The reason being that sine, you input an arc and it outputs a sine. This one, you input a sine function and it outputs the arc, the radian arc. So that's why they call that. But again, mainly know the shapes, know that they have endpoints. That's probably the key thing to know. Notice like what the difference is. So the sine, inverse sine kind of looks like tangents or an x cubed. And then inverse cosine is kind of doing its own thing. So